The heat transfer capacity is influenced by the heat transfer area and the heat transfer coefficient. The needle pipe used in Retermia's heat exchangers is composed of several fins, needles, and a structural pipe, inside which the brine flows. Needles form a larger heat transfer area for airflow. The needle construction causes air molecules to collide with the heat transfer surface even at low air velocities. This results in efficient, turbulent heat transfer from air to brine. Retermia's technology offers the possibility of serving several air handling units with one heat recovery and cooling system. This is possible because the needle heat exchanger does not have a so-called laminar velocity, below which thermal efficiency would plummet. A Retermia solution serving several air handling units is reliable, hygienic, flexible, and easy to manage, and for this reason favored by hospitals. Air intake takes place via a louver in the outer wall. Distance between blades in the louver is wide and there is no steel screen. Energy-consuming electric heating is not needed. The needle heat exchangers on the supply side are located in the air intake chamber right after the louver. The needle heat exchanger functions as a G3 level pre-filter, preventing snow and moisture from intruding the ventilation system. Supply air is dry as it reaches the filter in the supply air handling unit. Needle heat exchangers are serviced via the service hatches that open from the top. Brine connections are located on the bottom of the devices. Air intake to the supply air handling units takes place through the back wall of the air intake chamber. One Retermia heat recovery and cooling system serves several air handling units. When air handling units operate at partial airflow, a larger heat transfer air per cubic meter of air is achieved. Because heat transfer in the needle heat exchanger is turbulent even at low air velocities, thermal efficiency increases at partial airflow. Exhaust air units installed on the roof serve as exhaust coils for the heat recovery system. One exhaust air unit serves several small air handling units. This allows for optimal needle heat exchanger design, resulting in savings in investment costs. In addition, the devices are easier to install and system flexibility increases. Spare space can be left in the air intake chamber in case the number of air handling units increases in the future. The simultaneity factor of air handling unit operation can be taken into account when designing the heat recovery system. Far fewer glycol networks have to be constructed compared with a system where each air handling unit is equipped with its own heat recovery device. This means savings in piping and automation systems investment costs. There are fewer devices to serve. This system is more flexible and easier to manage. With needle heat exchangers, high thermal efficiency is achieved with low air and brine side flow resistances. This results in low fan and pump energy consumption. In addition to thermal energy from exhaust air, heat loads from the cooling network can also be utilized in the heat recovery system. Thermal efficiency of heat recovery is high in Retermia systems even at low outdoor air temperatures. This decreases the maximal heating power demand of the heating system. In district heating applications, this leads to lower basic fees. The thermal efficiency of heat recovery increases when air handling units are operating at partial airflow. Snow and humidity do not disturb the operation of the air handling system. Additional filter changes due to moist filters are avoided. Air volume flow rate and supply air filtering class remain at design levels during all weather conditions. The Retermia system brings savings in filter costs. With needle heat exchangers, high thermal efficiency is achieved with low air and brine side flow resistances. Fan and pump energy consumption is lower than in a conventional heat recovery solution. Thermal efficiency is almost constant in the Retermia system, regardless of outdoor air temperature. This means lower basic fees for district heat. In addition, The thermal efficiency of heat recovery increases when air handling units are operating at partial airflow. A heat recovery and cooling system serving several air handling units lowers the investment costs. The internal heat loads of the building can be utilized in the heat recovery system at low cost. This increases the annual efficiency of heat recovery. In the traditional solution, each air handling unit is equipped with individual heat recovery. In a Retermia system serving several air handling units, there are fewer piping systems. This makes the system more flexible and easier to manage and service.